Thanks, everybody. Welcome to Lucy and Solr Revolution. That was a great intro earlier. Thanks for coming to our talk. This is Solr Highlighting at Full Speed. I'm Tim Rodriguez. I work at Bloomberg. Many of you probably are familiar with our financial products or news products. We're the premier financial news and information provider. And I'm the vertical search team lead at Bloomberg. We work on a couple of different Bloomberg products. One of them is Bloomberg Law, which is what we're going to be focusing on today. I'm here with my colleague Dave Smiley, who's been helping us with a lot of that work as well. So before we get started, just a little bit of an agenda. We're going to first tell you a little bit about legal search and why it's different than maybe some of the other search domains that you're familiar with, and then how that led into some of the special business requirements that we had. Then we're going to back off and do an overview of the existing highlighters in Solr, and then step into some of the work that we've done to improve the standard highlighter. And then ultimately, we're going to tell you about the unified highlighter, which is a new highlighter that we're excited to show you today. And then hopefully, if we've timed this all right, there'll be some questions at the end. So Bloomberg Law, what's Bloomberg Law? Bloomberg Law is a suite of business tools for lawyers and legal professionals. It offers a variety of different features, whether it's helping them with their business development, drafting tools that help them compose their legal documents, analytics, or the one that's nearest and dearest to my heart, search. So if there's two things I want you to walk away with from legal search, at least for the focus of this talk, the first is that recall really matters. So where in normal search, typically you're focused on the first 1, maybe 10 results and getting that right answer to the top. For a lawyer, they're actually very focused on getting all of the right answers because there's more than one usually. Now, occasionally, of course, there's factoid questions where the first hit matters, but often really what they care about is that corner case that applies under some weird circumstance in the law that might destroy their case if you're on the defensive. On the flip side, if you're on the offensive, you want to find that corner case, that chink in their armor for the defendant so that you can argue your case more appropriately. The second thing is that these are large documents. We're talking very large documents. For example, Citizens United, which is a famous case, is over 130 pages long. And that is not the exception. We have documents in the hundreds of MBs in our system, so these are very long documents. Now, aside from all the scalability and performance challenges that introduces, it also introduces challenges for the researchers who are using our system, and that's because they rely on highlight. So because of that reason, they'll rely on highlighting to actually determine whether they want to open that hit and actually dig further into that result set before they commit that time to read that long document. So recall matters, and these are large documents. So how does that affect our requirements? The first is accuracy, and this is actually a subtle one that you might not think about at first. So legal users are actually accustomed to entering very complicated queries or using different grammars. And so this is something they're trained in law school to have all sorts of different query operators that they might use, whether it's within a paragraph, a sentence, things like that. But to start off with, let's just start with cafeteria plan and tax. So this is a quoted phrase. They're looking for the words cafeteria, followed by the word plan, and then tax anywhere else in the document. And this innocent-looking highlight looks pretty good until you realize that cafeteria benefit plan is kind of highlighted. And so this will actually cause a user to become suspicious about, well, why is benefit highlighted? I only search for cafeteria plan. Are my search results different than what I'm expecting? Are these the right results? And that's the worst thing in any search system that you can have, users not trusting your system. And as I mentioned, we actually have complicating matters. We have custom span queries, so our users can type in queries like this, which is insurance fraud as a phrase within a sentence of conviction. And these can all be nested and can get much more complicated and gnarly than that. The second thing that comes up is having just right digest sizing. So if this is a snippet of text and here are some highlights in it, where do you actually draw the line for the highlights? Do you give them the whole chunk? It's probably too much. Do you go and get just an individual sentence? That's probably too short. You want to give them just enough context, and this is just an example, but give them just enough context to help them understand whether or not they should jump into that document and spend the time reading it. The last one's kind of well, this extra requirement is actually something that you wouldn't necessarily expect. It's a little bit trickier. So, normally you have a full list of results. You click into one of those hits, and maybe you're showing a product or you're showing a location. But in this legal document, you're going to want to show highlights in that document to help the user understand where it is that their texts match, especially if it's a really large document. I mean, this is interesting because normally if you're indexing a very large document, there's lots of other things that you removed from it before you put it in the index, like formatting tags or extra metadata and all these different things that aren't in the original text anymore. So if you want to build a full fidelity representation of it, you're faced with two choices. Either you index the content twice, once in the stripped down version that you search over and once that has all of the content, or you analyze it on the fly. And if your index size is as big as ours, you're not going to want to store all of the text twice. So analysis became an important use case for us. The last requirement we'll talk about, kind of a niche one, but you see it a lot in expert systems, is zone highlighting. So one of the content sets that we have in our system are patents, US patents. And we offer the ability for our users to search within particular areas or zones of that text. So for example, if you want to search over the abstracts, all the abstracts in the US patents for the word bicycle, it's very important that you don't highlight the word bicycle in the claims, because then again, you're causing mistrust to the user. They're not understanding why that's being highlighted when they only search in the abstract. And of course, speed. Speed's always the thing that you think about first. But when you have all these other business requirements, it's kind of the last thing on your mind, although it's very, very important. So stepping back into an overview of the highlighters, we're going to go over them in the order that they've appeared in Lucene over time. The first one is the default or standard highlighter. It's important to note it's not actually called that. It's just called highlighter.java if you look inside Lucene. And this has better accuracy than the rest of them, accuracy as we measured or described before. And it can use two different offset sources, which we'll tell you a little bit more about in a second. You can either do analysis, or you could use term vectors in your index, but it's the slowest of the bunch. Later on, after term vectors were added, fast vector highlighter came on the scene. It offered better performance, but not as much accuracy as the default standard highlighter. And then the last, which is the fastest of the bunch, the postings highlighter came on the scene. It gave up a lot in terms of accuracy because it really focused on highlighting terms just as fast as possible. And for many use cases, that is fine, especially if you just have a simple keyword search. There is one corner case where it actually becomes slow, and that's if you use multi-term queries or wildcards, because it'll back off to analysis in that case to figure out all the terms that might be involved. And so we have that caveat there. So to give you some intuition about how this affects you and how you might make this choice and what's the index size trade-off, we have this graph here, and let me explain a little bit about it. It's actually, the horizontal axis is in multiples of the stored index size. So this is based off a sample Wikipedia data. And so what we're trying to show you is roughly how much of an expense do you spend for turning on all these different options in your index over and above the stored string, which helps kind of elucidate which highlighter you might want to use. Now we're assuming that you're going to store the string. This isn't the minimal index. If you look here, the blue is the stored value, how many bytes roughly that's taking. Terms is how much is dedicated to your terms index. And then positions, assuming you have any sorts of phrase queries that you're trying to observe, are there. So that's kind of like the standard index. That's the smallest you can get, unless you're really just looking for like docs that match something and you don't want to return the value. So you can see from here that analysis actually requires no extra data on disk above and beyond your normal index. But analyzing text on the fly is expensive. Term vectors are pretty heavyweight, if you can see, and that's because generally you can't get away from storing the terms and positions for your main index. So if you're using term vectors, you're adding that on top of your regular index. And you can also see that adding offsets to postings is much lighter than depending on term vectors. So what was our initial attempt? We actually figured it would be easier to add customizations to the default highlighter as needed, really start with that because it was the most accurate of the bunch. So the first thing we did was we added payload support to the memory index to support our custom span queries. You can see more of our work that was open sourced in Lucene 6155. We had investigated, as you might surmise from all the analysis we're discussing with you, that the postings highlighter and fast vector highlighter, but it didn't really meet the accuracy requirements, and we figured that would be harder to layer in than actually trying to make the standard highlighter fast. So we ran into some performance problems because highlighting was taking the bulk of our execution time. And by bulk, you'll see more when we get into performance numbers, but bulk really can mean multiples over and above your core search time. So highlighting, the second you do it, actually can drastically impact the speed of your search. So we decided to make it faster. We did some improvements to the standard highlighter. The first thing we did was we introduced fast uninverting of term vectors. The token stream really was just removing an expensive sort. That's also in Lucene. You can see that in 6301. We added support in the standard highlighter to depend on term vectors for phrase highlighting. It wasn't doing that previously. You can see that in 6034. But it still wasn't fast enough, and we're talking multiples. So again, you'll see the benchmarks, but it definitely wasn't where we needed it. So we did what you might expect. We then went to multi-threaded highlighting, which is everybody's favorite hammer. And so highlighting each doc is easily parallelizable. They're all separate, so you can highlight them independently. And for the most part, this actually worked. We got greatly improved performance, and we got greatly increased memory consumption. And so we ran this for a while. It did pretty well, but it was definitely challenging in our environment. And we had to be careful about how many threads we were executing in parallel. So there's this trade-off between memory and speed that we were doing. And it was still a sizable fraction of our query times at the end of the day. So there was more work to be done. So then we stepped back and we started reevaluating and said, it didn't look like we could do much more to the standard highlighter to get it any faster. Maybe, and this was an idea that was thrown about a bit, so we just explained postings highlighter as fast as a bunch, but it only does terms. Maybe if we analyze our query or classify it by just walking over our query tree to know that it's just a term query, we can federate to the postings highlighter for those examples. That would have worked up to as many term queries as we had, but as we explained, a lot of our user queries are more complicated in nature, but it definitely would have helped. And then it had the side effect where all those customizations we just told you about would have to be ported to each of the highlighters, or at least all the highlighters that we use, and potentially at the worst case, we'd have to repeat our work 3 times. And then we'd also have to turn on basically every knob and feature in our index and add postings on top of the term vectors, which we already had in there, which would increase the expense. So then we thought, okay, maybe that assumption that it would be easier to add speed wasn't a good one. What if we could add accuracy to the postings highlighter? It was, after all, the fastest of the bunch. We could try to add accuracy at least as good as a standard highlighter. And then while we're at it, especially because of that full doc highlighting case, we could add support for other offset sources too. Nope, should turn off my phone. So that'll support our full doc highlighting use case. But it would have been a huge job, as we knew, because we actually spent a lot of time with the standard highlighting, wrestling with the performance problems and things that we had there. So now I'm going to hand it off to Dave, who's going to carry you through the rest of the talk.
Hello? Okay, I think this works pretty well. So first I'm going to start with an overview of just what these highlighters need to do their job. They need offsets. They need to know at which character the word starts and ends for all the matching words. And those are offsets in the Lucene index. That's what it's called. And there's 3 ways to go about getting them. And there's analysis, which is going through your analysis chain, and it starts with an analyzer. I'm giving you a little bit of an overview of the Lucene APIs here on this slide. So you start with the Lucene analyzer, which you can get a token stream, and from the token stream you can register that you want the offset with the offset attribute, and then from that you can get the start and end offset. On the slide I omitted references to end offset, but for a start there's an offset end. Term vectors, a little more API involved. From your index reader, you can get the term vector. What's kind of interesting is that there is no termvector.java in Lucene. Instead, you get back a standard terms, but it's a special terms that's like a little mini index that's just for the particular document that you're interested in for a particular field. So once you get a terms, you can then get a terms enum, then you can get the postings. When you do that, you have to say that you want the offsets, otherwise it's not going to give it to you. And then as you iterate through the postings, you can get the start and end offset. So if you want to, and this kind of follows, by the way, in the order that these capabilities came about in Lucene. Because originally, there were no offsets in the index. You'd always have to analyze. And eventually, term vectors were added, and eventually offsets were added to term vectors. And you could go that route. And then eventually, offsets were added to the main index. And you proceed to do that by going to the index reader, you get a leaf reader, you get the terms, and at that point, you follow the same path that the term vector does in terms of the API, because it's the same API. The fact that it's the same API is convenient. I'm going to give you an overview of how the postings highlighter works in one slide, the kind of big picture. And it's pretty remarkable. One of the first things we did is really go through it in detail and try to understand, why is this thing so darn fast? What tricks does it do? And it's got lots of tricks up its sleeves. It's a very impressive chunk of code. The first thing that it does is that it gets all the stored content up front. The other highlighters do not do that. The other highlighters have a different API that don't even facilitate that. The other highlighters, you go to the highlighter to say, here's a document ID, here's the field, I want to highlight it now. It doesn't know the 10 documents that you want to highlight in total. It only knows one at a time as you ask for that highlight. The postings highlighter asks up front for you the entire document list up front. So it knows that you're going to highlight which specific 10 documents and which fields up front. And the very first thing it does is it grabs all the stored values and puts them in a little cache. Then it proceeds in a rather unintuitive order it actually highlights in field order, then doc ID order. And in turn, both of those are it internally sorts them. Even though your top 10 documents are in a particular relevancy ordered list, it internally is going to do its job in a way that's very, that kind of flows with the internal mechanics of the machine. The data on disk is going to be accessed here in the sequence in which it's going to be there literally on disk. And this is this notion of what's called mechanical sympathy that I really liked. I read about a few years ago, but the notion of kind of working with the machine, knowing what's going on under the covers and doing things in a way that aligns with the machinery to make it work faster. Now, a few of these tricks wouldn't necessarily even make sense for the standard highlighter, for example. The standard highlighter, if you're just doing analysis, you don't need to cache for a bunch of documents because you can work with each one at a time. But for doing postings, you want to get all the data from the stored value up front, because then you're going to hit the fields, and the fields are in field sorted order, and then they're in document order. So that's why this sequencing is in place. So at this point, the highlighter has a particular field, a particular document it wants to highlight, and then it loops through to highlight that document. The first thing that it does is for every term in your query, it gets a postings num for that term, which is an iterator of every occurrence of that word in the document in the field. So it gets a list of them. Now for multi-term queries, MTQ, and a multi-term query is a wildcard query or a fuzzy query if you got any of those kind of things. For those, you can't simply grab the postings num from the index because you're going to match a variable number of them. So it has to take a very different approach. And this is the case where the postings highlighter can be very slow, is that it analyzes the text to get a token stream, and then it's rather a clever hack, I would say. It wraps that token stream with the postings enum so that ultimately the postings highlighter wants postings enums to work. So it sort of figured out a way around, well, we analyze the text, wrap it with a postings enum, and then boom, okay, we've got a postings enum. So at this point, we have a list of postings enum, one for each term in your query, and a special magical one that's for all the wildcards in your query. Then there's the real kernel of the highlighter, the real guts of it, the real core loop as it loops through and does its job. And what it's doing is it takes all these postings enum, which again, where each of them are basically iterators of the occurrences of each word, it puts them into a priority queue, so it always knows what's the most closest term from the beginning of the text. As it goes through, it finds a matching term, and then it uses a Java break iterator to figure out where the passage delineation is. So this is customizable by supplying a custom Java break iterator. And by the way, there's a sentence one, and it's locale. There's the JDK provides a kind of a rich set of capability there. And so ultimately it builds up passages delineated by a break iterator, and it puts those into a separate priority queue in a passage scored order, and it has a scoring abstraction to figure out how well does a certain passage score. That's customizable, and its default algorithm is sort of it's a BM25 inspired model, which I think is pretty clever. So even though this is not, you think of BM25 and other relevancy for highlighting documents, but it's applying the same concepts to passages. And finally, at that point, you have a list of passages, aka snippets. Unfortunately, each highlighter has its own terminology. Then you need to format it, which is basically marking it up. So the first thing we did in Bloomberg was take the postings highlighter, copy it into our code base, and we gave it a new name befitting of the fact that this is not the postings highlighter anymore. It's going to highlight off of term vectors. It's going to do analysis. It's very much a derivative of the postings highlighter. So a lot of credit goes to Rob Muir, who wrote the postings highlighter. But the name didn't really make sense for the new set of capabilities. So we call this a unified highlighter. And it's mostly the same API as postings highlighter, which is very convenient. If you've ever used that one, this will be right at home. We did make some small modifications on the surface layer to make things easier. For example, with a postings highlighter, you'd have to subclass it to configure anything, whereas this one you can call setters to set various formatters and whatever you might need. But the internal guts have been reorganized, reshaped. The core pieces, I say, are still there, and we added a bunch more stuff. In particular, we actually reused some things from the standard highlighter, especially with regards to multi-term query processing and phrase highlighting as well. In some things, we didn't have to touch at all in the postings highlighter. Passage score, and passage formatter. In addition, it uses the Java break iterator, and that's still there too. There are three, I could go on talking for a while about all the things we did to make the unified highlighter, to how it evolved from the postings highlighter initial. But I'm going to highlight three in particular. And the first is accurate phrases. And this is a difficult requirement for the postings highlighter because the postings highlighter did not care about this. It does not. It takes every occurrence of any word in your query and highlights it wherever it sees it. So the approach we took was to look at the standard highlighter, which is the most accurate highlighter of the three in Lucene. And we took its approach and we basically ported it to the postings highlighter, now known as the unified highlighter here. So the standard highlighter has something called weighted span term extractor, and those working with Lucene for a while know that acronym by heart, probably. I do. And what it does is it takes your query and it looks for existing span queries, and it looks for any position-sensitive queries, like a phrase. And it turns those all into span queries, unless they may already be a span query, nothing to do. But so it converts them to a span query. That's one thing it does. Secondly, it also has some smarts about knowing whether or not certain queries need to be what's called rewritten. So if you have a wildcard inside of a position-sensitive query, like you want to find this wildcard matching within 10 words of something else, God help you if you have such queries, we do. And they're a challenge. But it has some smarts to detect when that's happening and what to do. And we leverage that right out of the standard highlighter's code, actually. So we were able to reuse some of that from the standard highlighter. We had a lot of work to say, okay, now we've got a bunch of span queries. And we conceptually did the same approach within the unified highlighter, but we had the details were different, so we had to kind of code up a bunch of code around making it work in the postings highlighter. In essence, what it does is it takes these span queries, it finds out the position spans that all these span queries are active within, which are word position spans. And then what we do is we basically wrap the postings enum. Remember, the postings highlighter wants a bunch of postings enum. So we basically wrap them filtered by position. And so it's conceptually similar to the standard highlighter, although the standard highlighter is filtering a token stream. Here we're filtering postings enums. One other thing I want to say about this approach is that we chose this approach based on Lucene 4.10, which was the code base we had at the time that we wrote it. If I had to write it right now, I would choose a fairly different approach. But I'll get to that later. It's a better segue for later slide. And that gets to the last point. This approach is good, but there are a couple edge cases where there's known, it's not perfect. There are some cases where it will highlight something where it probably shouldn't. The other major area of work in the unified highlighter was supporting the analysis offset mode. The other modes, postings, it already did postings. That was done. Term vectors was actually pretty simple, because remember the analysis APIs, I was telling you how to get offsets from things. The term vectors and postings, it's very similar. Once you get to a certain point, it's the same API. That was actually pretty straightforward. The only thing that was a little bit interesting was maybe handling wildcards. But the analysis offset mode is a bit difficult. So it's a little similar to the standard highlighter in the sense that it's dealing with the token stream. And it's similar in the fact that the standard highlighter will use a memory index to put the token into the memory index. This won't always do it. If your query is just a bunch of terms without any phrases involved, then we don't need to do that. But if you've got phrases, then we basically need to convert to span queries and execute them on memory index, et cetera. But we do some tricks beyond what the standard highlighter does. In particular, the standard highlighter will throw all tokens it sees into a memory index and highlight your query. But guess what? Your query's only got like maybe 10 words in it. Like, why not only index those 10 words, not every word that we'll see in this 100 megabyte document coming through? So there's some tricks we do like that by pre-filtering before we build up a memory index. We're just generally more memory efficient about how we do things than the standard highlighter. And also there are some details with the way the postings highlighter architecture was, especially with honoring. There's something called the position increment in the Solr schema you may see, and that's when you have, that configures the virtual word spaces between multiple values in a document. And it's important to us in B-Law, based on certain queries, that we honor that. Between one value and another, we don't want a phrase query matching across the last word of one value and the first word of the next. We don't want that. So we had to go through some extra hoops to make it honor the position increment gap. Yeah, okay. And then the third area, and final area that I'll really talk about with regards to the internals of the unified highlighter is a new offset source. You could say it's new, or you could say it's a hybrid of an existing one. It's debatable. So the offsets are still coming from, this is a new offset mode in which the offsets still come from postings. However, we also index light term vectors. I say light because it's just the terms. And that's less than half of the full term vector weight. If you remember earlier, the cost of indexing, the size, and the full term vector was the longest bar, but only half of that extra is just for the term vector terms. And if you want to highlight wildcards fast, what you need to do is you need to know what are the unique set of terms in the specific document. And that's exactly what a term vector is. It is the unique set of terms in that document. So this is a hybrid mode where we look at the query, and if we don't see any wildcards, then we don't bother with the term vector at all. But the moment we see a wildcard query, we switch to this offset mode where we take the term vector and we basically filter the main index with the term vector on top of it. There's some benchmarks coming up for that. And we're able to reuse a bunch of code we've already done in the process of developing this. So this is sort of a new hybrid offset mode. So benchmarks, I'm really happy about how this turned out. So the Lucene has a benchmark module, and it has a Wikipedia set of benchmark infrastructure. Thank you. And I basically indexed 200,000 documents. Wikipedia documents are probably a decent size, maybe bigger than most people's data, but it's also much smaller than ours, so it's kind of like a happy medium in terms of our requirements and other people's requirements. I know some people are indexing entire books, and so they would certainly benefit from this highlighter. And so the base search speed is a 1x on the top, and the three right columns are a sample set of term queries. You know, there's some Boolean stuff in there, and or this or that word, right? And there's a phrase query list and a wildcard query list, and and below that we have the highlighters, and these are all multiples of standard search because it obviously you have to do some work to do highlighting. It's all going to be somewhat slower than the 1x, and these are ranked by analysis mode. So we have the analysis offset mode, we have the full term vectors mode, then we have postings, and finally postings with light term vectors. And the main takeaways here, I mean, your mileage may vary, but the main takeaway here is that it is much faster than the standard highlighter. The other ones, it's competitive, maybe it's faster. I'm not going to say it's necessarily that much faster than the others. And the last mode at the bottom, postings with term vectors, that's a real sweet spot. Because with that, you get the speed of the postings highlighter. But if you have a wildcard query, we can do the fastest job than any other highlighter can do. And yeah, those are the main takeaways I want to say from the benchmarks. Oh, and there's one thing that I think there's a new realization here. As people start using the unified highlighter more, I think there's less and less of a case now for doing full term vectors. Because right now, before this highlighter, the use case was, you care about accuracy. Maybe you don't care quite as much as the standard highlighter, but you're willing to deal with the fast vector highlighter. That was your main option. But now you should use the unified highlighter for that scenario. There's more we could do with this highlighter. In particular, we could take the accuracy even beyond where it is right now. In particular, there's a highlighter in LUAC that addresses some of the concerns in these bullets above. And I'd like to see the relevancy improved even more. There was a clever requirement articulated in the Lucene JIRA about, it'd be nice to have passages that show a more diversity of terms across my query. I think it'd be wonderful, and I'd love to, see that happen. That'd be great. And there's an option called require field match in Solr that is honored by the standard highlighter and fast vector highlighter. And that's useful when, if your query references specific fields, the unified highlighter and the postings will demand that you can only highlight based on those words for the same field. But sometimes you've got like an all text kind of field that you index, and you don't necessarily index all your fields. You might want to highlight lots of fields that are just stored against an all text. So that's a scenario where you would use require field match. And right now, we only support true in this value. So in summary, highlighting is very important to legal search, and I think in many other domains, of course. And we explained we've explained the highlighters that exist in Solr. There's also one out there called the Wikipedia Experimental Highlighter I recently became aware of that I think is very cool. And finally, of course, the unified highlighter, which I really hope becomes the default highlighter for most people. I certainly think it should be the default highlighter that people go to use first. There are some cases where you might need one of the others that I know of, but hope maybe in time we can shore up those differences. So with that, thank you, and I'm really interested to hear about what your use cases are for highlighting. That's it.
So we got a couple. Yep. I have room. Yeah, go for it.
Yeah. Sure. Yep.
Faster than
Why is postings with term vectors faster than what?
for terms and phrases, you have like 1.7 versus 1.5.
So there are some, so the one thing I'll disclaim about these benchmarks, I ran them a bunch of times. I was trying to get them to be stable. In each case, my end message ended up being the same. It's either competitive or faster than the other highlighters. It's way faster than standard. That never changed. But the details, like for example, the 1.5 and the 1.6, those should be, one of them should be identical, but it's not. Sometimes some test runs it was faster, sometimes it wasn't. There's one thing I want to take away that I think is very cool here, by the way, that we weren't necessarily expecting, and that is when we added the phrase support to this, we thought it would be a little slower because we got to do this extra work to make sure we get accurate phrases right. It actually ended up being faster, and that's the difference between the 1.3, is it 1.3 and 1.5? Because the post, yeah, I think it's 1. I'm already confused right now. Anyway, it ended up being faster, and I'm like, wow, how could that be? And it's because, yes, we're doing some upfront work to figure out, at which positions do these words matter and the other ones don't matter. But that also frees up downstream from that. We have to do all sorts of passage delineation and stuff and figuring out where, we have to use a break iterator to know where the passages are. But if you filtered out a bunch of potential passages from ever being passages in the first place, you avoid the use of, you avoid even having to reference the break iterator in more times. And it turns out that the break iterator is, by the way, kind of a bottleneck here. So in B-Law, we use a break iterator that's very simple because we've pre-computed exactly what the paragraph is sent to linear star. So we have a very trivial one. And you can find it, if you have those that use case too, there's a Lucene postings highlighter package has a custom character break iterator you can use as well. And that makes it, here I just use the standard Java text sentence break iterator. But to make the differences even more dramatic, you could use if you're able to use a simple character-based break iterator, that's going to make certain numbers here show even more beneficial to the postings and unified highlighter. In particular, the fast vector highlighter, somehow it's not as sensitive to the break iterator performance as the unified highlighter is.
There's one more thing we should mention about these numbers. So these are actually multiples above your, including your search time. So if you look at unified highlighter terms with postings with term vectors, 1.5 times doesn't mean you're spending 1.5 in addition to your search. It's really 50% extra from your original search time. So just something to clarify there. It's still a helpful way to think of it. So it's like if I turn on this feature, my search times are increasing 50%, is really what that's saying. Next.
Doesn't highlight text at the bottom of a 10 megabyte document?
Yep.
Yeah, there's a configurable limit when you want to end. And by default, it's something like 50K, but we have that at like 10 megs.
How does
Way
it
higher.
impact performance?
We didn't, I guess one might go about benchmarking a chart of changing that number, and I have no idea what that curve would look like. Well, I have some indications. So, for example, the postings highlighter, if you highlight with postings, then you'd probably have a nice logarithmic. In other words, no matter how far you push that back, there are only so many cases where your term is somewhere. But on the other hand, if you have to analyze, you're on the order of the size of your document. Even if you have term vectors, your term vectors, that's where your cost is fetching those term vectors from disk is expensive. They're so big. So, and your term vector is itself, a factor of your size of your document. So, I think if you've got postings, then you can push that number way out there.
I was wondering, in the standard highlighter, there was the issue where, in case of synonym lists, where you have phrases that match each other, but in the context of terms are different, the highlighter just gets confused and highlights a lot of things. Has this
There are cases where the standard highlighter will highlight things that it shouldn't. It always, it won't go the other way. In other words, it won't miss something, but it will sometimes highlight something it shouldn't. And an example of that is when you have, here's a phrase like hello world, and I'm looking for that within 100 words of something else. And if it will highlight hello and world as individuals anywhere within there as an example. And that's not ideal, and it'd be nice if we could address that. I know how to do that. There's a highlighter in LUAC that the Lucene 5.3 exposed a new API that allows us to go about doing that in an accurate way. It'll take some time to actually leverage that, though, because we basically need to rewrite the accurate highlighting.
Speaking of which, Alan Woodward's in the back over there.
Yeah.
He did a lot of that work, so.
Yeah.
Definitely know what I'm as well. Next question.
It was just committed. Oh my gosh, did we forget?
No, we
Yeah, so I brought up the summary slide, but I didn't actually mention. It's open sourced. This is available for Lucene. It was just recently committed for, so it's on the 6.3 release. So whenever Solr 6.3 happens, you're going to get, well, it'll be at the Lucene level. There is a Solr patch that has not yet been posted. We certainly have one internally, of course, but we'd have to, make it an extra test or two.
So we do have some documents in other languages, but we don't have, like, they're primarily Romance languages, and they're minority content for us right now. It's focused primarily on English, so we haven't dealt with any of those problems yet. You're talking about the postings highlighting algorithm?
I agree. Okay, so one of the things we wanted to do is make it a little more extensible, and we could even do more than that. And I definitely agree, because it turns out that the current algorithm that it does is fine for us at the moment, so we're happy with it. But I've seen cases where, like Eric Hatcher was talking to me, what if we get, interesting data in the payloads, like offsets into OCR text, and what if you want to return the offsets from the payloads, like can you do that? And I'm like, okay, well, I know the code that would be modified, and it would indeed be right there. So it'd be wonderful if you could override that. I think there's one thing in particular that needs to change, and that is passage is still, we didn't make that public. We should have snuck that in. No, we didn't. So the annoying thing about, there's a trade-off in Lucene about making stuff exposed versus not. If we could make passage completely public, then that would be wonderful. Then you could override it easily, and actually, because right now I think it's package protected, which means the moment that's package protected, that means that you can't use the passage format or passage score because you can't even create a passage in the first place. So I think we need to make that public. If it's not already, I could be mistaken. And then you can at least override that method.
I just want to add one more thing. We have done customizations on top of that. So what we've open sourced is all the stuff that's general, and then we have some customizations for some of those features we talked about, like zone highlighting and full document highlighting, Goldilocks passage sizing.
Mm-hmm.
Next question? I think we haven't got to that yet. Yep.
Yeah.
So are you referring to, like, in the analysis mode, or just in general with postings?
You still have to read the content.
Yeah, there's.
Yeah. We thought about that a little bit. We didn't ultimately take that much further, but you could kind of think of ways of chunking that up maybe. There's possibilities there to make that better.
So far, it hasn't been a problem. And actually, one thing I should add is we talked about multi-threading. We actually never brought multi-threading back to this approach. So these are all serial. So it's highlighting, if you have 50 results, it's generating passages for all 50 of those. And the good news is we got it fast enough that it was reasonable at that point in time. So we're not sure. Multi-threading might make it faster, it might not. But just to give you a sense of, like, how, how much faster it is now, so the random access I/O didn't come up as a factor.
we out of time?
Yeah.
Okay. Yep. All right. Thanks, everybody.